Tonight, we are going to look into the deepest abyss of the cosmos and uncover the terrifying reality that the universe is actively deceiving us. For decades, we comforted ourselves with the illusion of a measurable reality. We memorized the numbers, catalogued the stars, and drew neat boundaries around the visible cosmos, believing that a larger telescope would simply bring the edges of the map into sharper focus. But the James Webb Space Telescope didn't just peer further into the dark, it tore the map to shreds. What it found hiding in the ancient light is not just a universe that is impossibly vast, but a universe that is fundamentally broken. The laws of physics we rely on are fracturing, the horizon is closing in, and the true scale of what surrounds us is vastly more hostile and unpredictable than we ever dared to imagine. Let us begin by destroying a number that you likely accept as absolute truth. For most of modern history, we have been taught that the universe is 13.8 billion years old. Because light is the fastest moving phenomenon in existence, bound by a strict physical speed limit of roughly 186,000 miles per second, it feels like basic common sense to assume that the absolute edge of everything we can see should sit exactly 13.8 billion light-years away in any given direction. That math feels clean, intuitive, and safe. It is also completely wrong. The true diameter of the observable universe does not measure 27.6 billion light-years across. It measures an incomprehensible 93 billion light-years. To understand how a 13.8 billion-year-old cosmos spans an expanse nearly 7 times wider than light could possibly travel in that time, you have to discard the idea that space is just an empty box where galaxies float. Space is an active, stretching fabric. Imagine trying to run towards someone on a moving walkway, but the walkway is continuously stretching beneath your feet, pulling you backward. When a distant galaxy emitted its light 13.5 billion years ago, it was much closer to our location. But as that light began its agonizingly slow crawl toward Earth, the cosmic treadmill engaged. The space between us and that galaxy expanded continuously, carrying the physical galaxy outward while its ancient photons fought their way across the growing void. By the time that light finally crashes into the golden mirrors of the James Webb Space Telescope today, the galaxy that emitted it is no longer 13.5 billion light-years away. It has been swept out to a present-day distance of roughly 46.5 billion light-years in a single direction. When you look out into the deep sky, you are looking at ghosts. You are studying the fossilized afterimages of objects that have long since been dragged toward the edge of an ever-expanding abyss. For years, we stared at this 93 billion light-year sphere and believed we understood its basic rules. We thought it was a quiet, sparse arena where matter slowly and patiently organized itself from the darkness. When we looked into the deep cosmic past with earlier instruments like the Hubble Space Telescope, the universe seemed to thin out. The darkness felt empty. But that emptiness was a lie born of our own biological and technological limitations. As space expands, it stretches the light traveling through it, pulling the short, energetic wavelengths of visible light into long, sluggish infrared waves. By the time the light from the deepest edges of the 93 billion light-year expanse reaches us, it is completely invisible to human eyes and to telescopes built to see like we do. The universe wasn't empty, it was simply broadcasting on a frequency we could not tune into. The James Webb Space Telescope was explicitly engineered to capture this invisible, red-shifted frequency, built with a 21-foot beryllium mirror coated in microscopic gold and parked 1 million miles from Earth just to catch these ancient, exhausted photons. The expectation was that Webb would finally illuminate the quiet, fragile dawn of our 93 billion light-year bubble. Instead, it delivered an unprecedented shock to the foundation of cosmology. It didn't just peer further into the dark, it proved that everything we thought we knew about this massive expanse is fundamentally deeply wrong. The terrifying reality of this scale is not merely the sheer volume of space. We have known the universe was massive for a century. The true terror is what Webb found hiding inside it. The 93 billion light-year universe is not empty, nor is it a patient, slow-moving machine. It is choked with massive galaxies that formed when the cosmos was barely 300 million years old. It is filled with monstrous structures and supermassive black holes that defy the strict laws of physics we assumed governed the entire expanse. When Webb captured hundreds of thousands of distinct, fully formed galaxies in patches of sky previously thought to be desolate voids, it proved that our understanding of this 93 billion light-year arena is essentially broken. We built a map of reality based on mathematical models, and Webb's first deep stares into the infrared dark confirmed that our map does not match the territory. The true terror of this scale is our absolute ignorance of what is actually happening inside it. But the 93 billion light-year lie goes even deeper than our misunderstanding of its contents. This incomprehensible span, 46.5 billion light-years in every direction, is not the universe. It is merely the observable universe. It is a local bubble defined entirely by the speed of light and the passage of time. The edge of this sphere is not a physical wall, nor is it the end of space. It is an event horizon of information, a one-way membrane beyond which reality simply continues, permanently out of our reach. By analyzing cosmological data and applying advanced statistical modeling, physicists have calculated that the true universe extends far, far beyond this boundary. Our 93 billion light-year bubble is just a fraction of what exists. In fact, conservative estimates indicate that the total universe is at least 250 times larger than the observable portion we can map. Let that sink in. If the entire 93 billion light-year expanse of everything humanity has ever seen, measured, or theorized were a single page in a book, the true universe would require a book at least 250 pages long. Or worse, if space is perfectly flat, it extends infinitely without end, in all directions. Everything the James Webb Space Telescope is dismantling, the impossibly massive early galaxies, the rule-breaking black holes, the fundamental violations of cosmic architecture, is occurring within less than 1/250th of the actual universe. We have spent centuries constructing a narrative of reality from inside a tiny, localized droplet of space, completely blind to the infinite ocean surrounding us. Webb has not revealed the edge of the universe. It has revealed that we are trapped inside a microscopic sphere of visibility, surrounded by a cosmos that operates on rules we do not yet comprehend. And as we are about to see, the first structures Webb found in this ancient darkness do not just challenge our mathematical models, they threaten to break the physical timeline of creation itself. To truly understand the terror of what the James Webb Space Telescope has uncovered, we must first travel back to the absolute beginning and immerse ourselves in the darkest period of cosmic history. Imagine a universe entirely devoid of light. After the initial unimaginable heat and violence of the Big Bang began to subside, the cosmos expanded, and as it expanded, it cooled. Approximately 380,000 years after the initial spark of creation, the universe had cooled just enough for protons and electrons to finally bind together, forming the very first atoms of neutral hydrogen. When this happened, the primordial fog of free-floating electrons that had trapped all radiation finally cleared, allowing the first flash of light, the cosmic microwave background, to travel freely through space. But after that brilliant flash, the lights went out entirely. The universe entered a period known to cosmologists as the Cosmic Dark Ages. For hundreds of millions of years, there were no galaxies, no stars, no planets, and no light whatsoever. There was only a vast, expanding void filled with a cold, invisible ocean of neutral hydrogen gas and the silent, unseen scaffolding of dark matter. It was a universe of total, impenetrable blackness. The transition out of this suffocating darkness is a period scientists call the epoch of reionization. This is the theoretical era when the very first primitive stars and galaxies finally ignited, unleashing fierce ultraviolet radiation that began to burn through the neutral hydrogen fog, ionizing the gas and gradually making the universe transparent. Understanding exactly how and when this happened was not just a secondary goal for astronomers, it was the James Webb Space Telescope's primary mission. Humanity spent decades and $10 billion constructing an instrument with a 21-foot golden mirror, parking it 1 million miles from Earth in the freezing void of space, specifically to peer back across 13 billion years and witness the precise moment the cosmos turned the lights on. Before Webb opened its golden eye, the scientific community had a deeply entrenched, mathematically elegant expectation of what that cosmic dawn would look like. This expectation was defined by the standard model of cosmology, known as lambda cold dark matter. This framework had been refined over 4 decades of meticulous observation and supercomputer simulations, and it passed almost every test astronomers threw at it. It provided a comforting, logical, and highly structured narrative for how existence assembled itself from the void. Under the lambda cold dark matter model, the universe is governed by the patient, methodical force of gravity. The rules of this model demand a process known as hierarchical assembly. In simple terms, this means that small things must form first, and larger structures can only be built gradually over immense stretches of time by merging those smaller pieces together. In the deep darkness of the early universe, regions of dark matter that were slightly denser than average exerted a faint gravitational pull. Over tens of millions of years, they slowly gathered more dark matter, growing into vast, invisible gravitational wells called halos. Only then could ordinary hydrogen gas begin to patiently pool into these unseen valleys. The gas had to gradually cool, lose its energy, and fragment before it could finally collapse under its own weight to ignite the very first stars. This is a profoundly slow, inefficient, and agonizingly gradual process. Gravity is powerful, but it takes time. You cannot build a skyscraper before you have poured the concrete, and you cannot pour the concrete before you have surveyed the land. Because of these strict physical speed limits, every cosmological model predicted that the universe's first galaxies would be incredibly small, incredibly faint, and incredibly rare. They were expected to be fragile, primitive smudges of starlight, barely clinging to existence, taking hundreds of millions of years to mature into anything resembling the massive, structured galaxies we see in the local universe today. When astronomers pointed the James Webb Space Telescope into the deepest, oldest corners of the night sky, they were fully prepared for a landscape of scarcity. They expected to find a quiet, tentative cosmos just taking its first hesitant steps out of the dark. What they found instead shattered 40 years of established theoretical physics. When the telescope's advanced deep extragalactic survey, known as the JADES program, began meticulously analyzing the faint infrared photons arriving from the edge of the observable universe, the data did not reveal a quiet, empty dawn. It revealed a cosmos that was already crowded. It revealed a universe that was brilliantly illuminated, choked with massive structured galaxies that were producing staggering amounts of starlight. The universe was not slowly waking up, it was already operating at a terrifying, feverish pace. The absolute collapse of our expected timeline was crystallized by the discovery of a single, impossible object. Deep in the survey data, astronomers identified a galaxy carrying the cold, bureaucratic designation JADES-GS-Z14-0. At first, it appeared as just another faint, reddish smudge. But when researchers pointed the telescope's near-infrared spectrograph at this object, splitting its ancient light into its component wavelengths to read its cosmic fingerprint, the resulting data sent a shockwave through the astronomical community. The spectrograph measured a redshift of 14.32. In the physics of an expanding universe, redshift is the ultimate measure of both distance and time. As light travels across billions of light years, the very fabric of space stretches beneath it, pulling the light waves into longer, redder frequencies. A redshift of 14.32 translates to a specific, undeniable moment in the history of reality. It means the light captured by the telescope left this galaxy when the universe was precisely 290 million years old. To comprehend why that number is so mathematically horrifying, you must set aside the vastness of human history and think in the brutal scale of cosmic time. Our universe is roughly 13.8 billion years old. 290 million years is a mere fraction of that timeline. It represents exactly 2% of the universe's current age. If you were to compress the entire 13.8 billion year lifespan of the cosmos into a single 12-month calendar year, with the Big Bang occurring at the very first second of January 1st, the galaxy JADES-GS-Z14-0 was fully formed and violently burning by the first week of January. Let us compare that to a timeline you are intimately familiar with, the ground beneath your feet. The Earth has existed for approximately 4.5 billion years. The dinosaurs reigned over our planet for roughly 165 million years before being annihilated. Now look back at the young universe. In less than double the time it took for a single species of reptile to evolve, flourish, and go extinct on one tiny rock, the entire universe managed to emerge from a featureless quantum fireball, construct the invisible scaffolding of dark matter, gather incomprehensible oceans of primordial gas, ignite millions of thermonuclear stellar engines, and organize them into a massive, functioning, galactic metropolis. This speed defies every logical boundary set by the lambda cold dark matter model. A galaxy at 290 million years after the Big Bang is not supposed to be anything more than a barely detectable flicker. But JADES GS-Z14-0 is not a flicker. It is an absolute monster. The data revealed that this galaxy measures over 1,600 light-years across. It is incredibly bright, and the source of that blinding luminosity is not a trick of an actively feeding black hole, but the combined, ferocious output of hundreds of millions of young, massive stars. Think about the mechanical requirements of what you are hearing. The Standard Model dictates that typical galaxies convert only a tiny fraction of their available gas into stars, a slow, highly inefficient process constrained by the outward pressure of heat and radiation. To assemble hundreds of millions of solar masses worth of stars within a mere 290 million years, this galaxy would have had to convert nearly 100% of every available atom of gas into stars at an impossibly sustained rate, starting from the very first moment gas was capable of cooling. This level of star formation efficiency is not merely unlikely under our current understanding of astrophysics, it is essentially forbidden by the laws of thermodynamics. Yet the terrifying reality of JADES-GS-Z14-0 goes far beyond its mass and its brightness. The true horror lies hidden within the chemical signature of its ancient light. When astronomers analyzed the spectrum of this impossibly early galaxy, they expected to find nothing but hydrogen and helium. The Big Bang was a furnace of immense heat, but it was incredibly brief. It only had the capacity to forge the lightest elements in existence: hydrogen, helium, and a tiny trace of lithium. Every single heavier element in the universe, the carbon in your DNA, the iron in your blood, the silicon in the earth, and the oxygen you breathe, did not exist at the dawn of time. They are the byproducts of cosmic violence. They can only be forged inside the crushing, multi-million-degree cores of massive stars. For those elements to exist in deep space, a star must be born. It must burn through its entire nuclear fuel supply over millions of years, and then it must die in a catastrophic supernova explosion, violently scattering its newly forged heavy elements into the surrounding void. Only then can the next generation of stars sweep up that enriched gas and incorporate it into their own structures. Therefore, chemistry is a clock. The presence of heavy elements is absolute, undeniable proof that an entire generation of stars has already lived and died. When the combined observations of the James Webb Space Telescope and the Atacama Large Millimeter Array analyzed JADES-GS-Z14-0, they detected a glaring, unmistakable spectral emission line. They detected oxygen. They found oxygen sitting in a galaxy that existed when the universe was just 290 million years old. The implications of this single chemical signature are profoundly disturbing. Under the models that existed before this telescope launched, the very first primitive stars were not expected to even begin igniting until the universe was somewhere between 100 and 200 million years old. But for oxygen to be radiating from a fully assembled galaxy at the 290 million year mark, the entire agonizingly slow chain of cosmic creation had to have been drastically, violently compressed. The very first theoretical monster stars, known as population 3 stars, must have formed almost immediately. They must have burned with a terrifying, short-lived intensity, detonating as hypernovas to enrich the primordial hydrogen clouds, allowing a second generation of stars to form, gather into a massive galactic structure, and shine brightly enough to be seen across 13.5 billion light-years of expanding space. All of this occurred in an interval of time that our mathematical models dictate is barely enough for the process of star formation to even begin. As one of the lead researchers bluntly stated, the finding was completely unanticipated. In the strict, precise language of cosmology, this is not a minor anomaly, it is a fundamental crisis, and JADES-GS-Z14-0 is not an isolated freak of nature. It is the vanguard of a massive systemic failure in our understanding of reality. As the telescope continued its deep surveys, it began cataloguing an entire population of these objects, galaxies appearing at redshifts above 10, completely defying the limits of how fast matter should be able to organize itself. Researchers poring over data from the Cosmic Evolution Early Release Science Survey identified a half-dozen galaxies formed within the first 500 to 700 million years that contained up to 100 billion times the mass of our Sun. For context, that means the infant universe was somehow building galaxies with stellar masses comparable to the modern-day Milky Way, but doing it in less than 5% of the time the Milky Way had to assemble itself. These objects defied the models so violently and so consistently that the stunned researchers who found them gave them a new, informal classification. They called them universe breakers. And the name is terrifyingly accurate. If the lambda cold dark matter model is correct, these galaxies cannot exist. Gravity is too weak, gas cooling is too slow, and the universe was simply too young. The standard model demands a slow, hierarchical assembly, a patient gathering of dark matter and gas over billions of years. But the James Webb Space Telescope has proven that the universe did not slowly wake up. It sprinted. It bypassed the patient rules of hierarchical assembly and somehow forced massive, chemically enriched structures into existence in an impossibly compressed time frame. The early cosmos was not a delicate, quiet dawn. It was an era of ferocious, hyper-efficient violence. It was a universe that operated at a speed and an intensity that simply does not happen anymore. The terrifying mystery we are left with is not just how these universe breakers formed, but what unknown, unrecognized physical laws permitted them to do so. If our foundational model for how gas collapses, how stars ignite, and how galaxies assemble is completely invalidated by the very first things to exist, then we are entirely blind to the true mechanics of creation. We have spent our entire scientific history studying the slow, aging embers of the modern universe, mistakenly believing we understood the fire that started it all. Webb has forced us to look directly into that ancient fire, and what it shows is a machinery of creation so vastly overpowered and incomprehensibly fast that we must now entertain the deeply unsettling possibility that we do not actually understand how our own universe was built. To truly grasp the horror of the anomalies lurking in the early cosmos, we must first look closer to home and understand the delicate, seemingly permanent balance that governs our own galactic neighborhood. Deep within the core of the Milky Way galaxy lies a sleeping giant, a supermassive black hole known as Sagittarius A star, weighing approximately 4 million times the mass of our Sun. While 4 million solar masses sounds like a terrifying concentration of gravity, in the grand architecture of our galaxy, it is actually quite small. The Milky Way contains roughly 60 billion solar masses worth of stars. When you run the math, you find that the mass of our central black hole represents only about 1/10 of the total stellar mass of the entire galaxy. In the present-day universe, this relationship is not a coincidence. It is a strict, universally observed rule. Across billions of years of cosmic time, black holes and their host galaxies appear to be locked in a patient, harmonious dance. The models dictating cosmic evolution assumed that they grew together in tandem. A galaxy gathers gas, forms stars, and slowly, over billions of years, a tiny fraction of that material filters down into the center to feed the black hole, maintaining a proportionate, balanced ratio where the galaxy always massively outweighs its central engine. We believed this 0.1% rule was a fundamental characteristic of cosmic architecture. But when the James Webb Space Telescope aimed its golden mirrors into the deepest infrared abyss, it proved that this harmonious balance is a modern illusion. The infant universe was not a place of balance. It was a place of extreme, terrifying disproportion, ruled by monsters that had vastly outgrown their cages. Hidden within the deep survey data, astronomers began cataloging a bizarre new class of objects that had no clean precedent in the local universe. Because their ancient light had been stretched by billions of years of cosmic expansion, they appeared as compact, intensely red smudges against the blackness of space, earning them the informal, almost harmless-sounding designation of little red dots. At first glance, researchers assumed they were looking at normal, albeit distant, infant galaxies. But when teams led by researchers like Jorrit Matthey at the Institute of Science and Technology Austria began extracting the spectral fingerprints of these 341 catalogued objects, the data shattered the illusion of a quiet cosmic dawn. These little red dots, existing between roughly 600 million and 1.3 billion years after the Big Bang, were between 10 and 100 times more abundant than any cosmological model had predicted, but their sheer numbers were nothing compared to the nightmare hiding at their centers. The supermassive black holes anchoring these ancient systems ranged from 1 million to 100 million solar masses. When astronomers compared the mass of these black holes to the stellar mass of the tiny, compact galaxies surrounding them, the equations broke. The 0.1% rule was completely annihilated. In the little red dots, the central black hole accounted for 30% or more of the host galaxy's entire mass. This is a factor 300 times greater than the locally observed relationship. In some of these systems, the black hole actively outweighs the combined mass of every single star in the galaxy. The relationship is entirely inverted. Imagine the Milky Way, but instead of a quiet core, it housed a gravitational beast 300 times larger, violently overpowering the entire galactic structure around it. These are not galaxies that happen to contain a black hole. They are massive, ravenous black holes that are barely wearing a galaxy as a disguise. This inverted ratio plunged astrophysics into a severe crisis. The models dictated that a galaxy must form first, patiently building its stellar mass, while the black hole slowly feeds on the leftovers. But the little red dots suggest that in the early universe, the black hole got huge first, wildly outpacing the galaxy around it, dominating the mass budget of the system while the stars were left as a minor afterthought. To understand why this rapid, disproportionate growth is not merely surprising, but physically alarming, you must understand that the universe possesses a strict, mathematical speed limit for destruction. Growing a black hole from a small stellar seed into a supermassive monster weighing millions of suns is not a matter of simply dropping matter into a bottomless pit. It requires time, and it requires overcoming a fundamental barrier of physics. As massive clouds of gas and dust fall toward a black hole's event horizon, the material cannot drop straight in. It spirals around the center, forming a dense, flattened ring known as an accretion disk. As this material crowds together, moving at significant fractions of the speed of light, immense friction heats the gas to millions of degrees. The disk becomes a blazing inferno, emitting blinding amounts of radiation, particularly high-energy X-rays. But light has momentum. It exerts a physical force. As the black hole feeds aggressively, the intense radiation pouring out of its superheated accretion disk pushes outward against the incoming gas. Gravity pulls the food in, but the light pushes the food away. If too much matter falls toward the black hole too quickly, the outward radiation pressure becomes so powerful that it literally blows the black hole's own fuel supply out into deep space. The black hole effectively chokes on its own light, preventing it from feeding any faster. This delicate balance between gravity pulling in and radiation pushing out creates a hard, theoretical ceiling on how fast a black hole can physically grow. In astrophysics, this maximum threshold is known as the Eddington limit. Because of this strict speed limit, even if a black hole feeds continuously at its absolute maximum permitted rate, assembling a supermassive black hole from a stellar remnant should take hundreds of millions, if not billions, of years of patient, steady accretion. The physics of matter falling into black holes imposes this strict speed limit, acting as an unbreakable law of thermodynamics. But the James Webb Space Telescope has revealed that the early universe was a chaotic, lawless frontier that simply ignored the rules. The most terrifying proof of this cosmic rebellion comes in the form of an object carrying the bureaucratic designation LID 568. Sitting at the center of a dwarf galaxy, LID 568 is a black hole observed as it existed roughly 1.5 billion years after the Big Bang. When combined observations from the James Webb Space Telescope and the Chandra X-ray Observatory analyzed the high-energy light pouring from this system, the data came back with a number that defied reality. LID 568 was not just eating efficiently, it was consuming matter at more than 40 times the theoretical Eddington limit. 40 times. This is not a minor anomaly, nor is it a slight miscalculation. It is an act of extreme physical violation. To put the absurdity of this measurement into perspective, if the Eddington limit were a highway speed limit of 100 miles per hour, LID 568 is tearing down the road at 4,000 miles per hour. The physics of radiation pressure dictates that this is entirely impossible. The outward force of the X-rays, screaming from its accretion disk, should have blown its gas supply into the intergalactic void long ago. Yet, LID 568 is gorging itself blindingly bright, completely ignoring the fundamental speed limits of reality. If it sustained this impossible feeding rate for just a few million years, the black hole would double in size in a fraction of the time physics permits. Faced with monsters that outgrow their cages and break the universal speed limits, theoretical physicists have been forced to propose terrifying mechanisms that describe an unimaginably violent early cosmos. To explain LID 568, scientists have turned to a phenomenon called super-Eddington accretion. For this to occur, matter cannot just be slowly spiraling into the black hole. It must be dumped onto the event horizon from all directions simultaneously in such an overwhelming, suffocating volume that the radiation pressure is simply drowned out. Imagine standing in front of an oscillating fan and trying to stop a roaring ocean-sized tidal wave. The wave wins through sheer, overwhelming mass. If massive amounts of dense, turbulent gas collapse onto the black hole all at once, the radiation cannot push it away fast enough, resulting in a short, violently intense feeding frenzy. JWST is suggesting that in the crowded, chaotic environment of the early universe, these extreme, rule-breaking feeding episodes were not rare flukes, but a common feature of cosmic architecture. But even super-Eddington accretion struggles to fully explain the sheer abundance of the little red dots, or how their central engines secured such an enormous head start over their host galaxies. This leads us to a second, even more disturbing theory. What if the early universe was bypassing the traditional life cycle of stars entirely? In the standard model, a black hole must begin as the remnant core of a dead star, weighing perhaps 50 times the mass of our Sun, which then must begin the agonizingly slow process of feeding. But the early universe may have possessed a terrifying shortcut. Cosmologists have proposed the concept of direct collapse black holes. In the highly pressurized, radiation-soaked environment of the young cosmos, a massive cloud of primordial hydrogen gas, weighing tens of thousands or even hundreds of thousands of solar masses, might have simply collapsed in on itself under its own immense gravity. Because this primordial gas lacked the heavy elements that normally allow clouds to cool and fragment into smaller stars, the entire massive cloud imploded directly into a singularity. This direct collapse would bypass the stellar phase entirely, creating a heavy seed right from birth. Instead of starting from a 50 solar mass remnant, the black hole begins its life already weighing 100,000 times the mass of our Sun, granting it a massive, unfair head start in the race to accumulate mass. A closely related theory suggests the existence of supermassive stars, theoretical leviathans hundreds or thousands of times more massive than typical stars, which burned ferociously for a few brief million years before detonating and collapsing into equally massive black hole seeds. Both the direct collapse and the supermassive star theories require highly specific, extreme conditions that simply do not exist in the modern universe, painting a picture of an ancient cosmos that operated under a vastly different, far more volatile set of rules. What the little red dots and the ravenous appetite of LID 568 ultimately reveal is a massive, structural failure in our understanding of how reality was assembled. The foundational models predicted a universe that was slow, patient, and deeply ordered. Instead, the James Webb Space Telescope has exposed a cosmos in its infancy that was violently chaotic, governed by overpowered engines, brutal imbalances, and extreme forces competing for dominance. The monsters were not hiding in the dark, they were the ones actively shaping it. We are forced to accept that the very laws of physics we thought were universal speed limits were routinely shattered by the universe when it was young, and if the universe was willing to break its own rules to build these impossible black holes, we must now ask what other foundational laws it violated. As we peel back the next layer of the cosmic dawn, we will find that it wasn't just gravity and mass acting in impossible ways. The deeper terror lies in the very atoms themselves, leading us to a discovery that threatens to break the physical timeline of creation completely. To truly comprehend the depth of the deception we are trapped inside, we must look beyond the sheer size of the early galaxies the telescope discovered and examine the very atoms they are built from. If the impossible masses and ravenous black holes of the infant cosmos challenge our understanding of gravity, the chemical signatures hiding within their ancient light threaten to completely dismantle our understanding of time. There is a fundamental law of reality that governs the physical world you interact with every day. The carbon forming the structure of your DNA, the oxygen filling your lungs, the iron carrying blood through your veins, and the silicon beneath your feet share a single, violent origin story. None of these elements existed at the dawn of time. When you strip away the complexity of the modern cosmos and rewind the clock to the absolute beginning, the universe was incredibly, brutally simple. The Big Bang was an event of incomprehensible heat and energy, but it was also incredibly brief. The extreme temperatures required to forge atomic nuclei lasted for only a matter of minutes. In that brief, fading window, the universe functioned as a primordial furnace, but it only had the capacity to forge the simplest, lightest elements in existence. As the cosmos expanded and cooled, it locked in a permanent baseline inventory of matter, vast oceans of hydrogen, a smaller percentage of helium, and an incredibly faint, almost negligible trace of lithium. That was it. For the first few 100 million years of existence, the entire periodic table of elements stopped there. Because of this strict limitation, every single heavier element in the universe is a byproduct of cosmic violence. They cannot simply manifest in the void of space. To forge carbon, oxygen, nitrogen, and iron, the universe requires highly specialized, high-pressure factories, and those factories are stars. A star is not merely a beacon of light. It is a continuous, millions of years long thermonuclear explosion held in a delicate state of equilibrium by the crushing weight of its own gravity. Deep inside the multimillion-degree core of a star, the immense pressure forces hydrogen atoms to violently smash together and fuse into helium, releasing the energy that makes the star shine. When a star exhausts its core supply of hydrogen, it begins a desperate, agonizing sequence of collapse and reignition, fusing heavier and heavier elements just to stave off the crushing weight of its own mass. Helium is fused into carbon, carbon into oxygen, oxygen into neon, and eventually, in the most massive stars, the core turns to iron. But forging these heavy elements is only the first half of the requirement. An element trapped in the dead core of a star is useless to the rest of the universe. To seed the cosmos with the building blocks of planets, chemistry, and eventually life, that star must undergo a catastrophic death. When a massive star finally exhausts its nuclear fuel, gravity wins the billions of years-long standoff in a fraction of a second. The star's core collapses inward at a significant fraction of the speed of light, hits an absolute density limit, and rebounds in a shockwave of unimaginable power. The star detonates as a supernova, an explosion so violently energetic that it can briefly outshine an entire galaxy. It is only through this ultimate sacrifice that the heavy elements forged deep in the stellar core are violently scattered into the surrounding interstellar void. Once expelled, these enriched clouds of gas slowly cool, mix with the primordial hydrogen, and eventually collapse again to form the next generation of stars. This new generation incorporates the heavy elements from the ashes of the old, allowing for the formation of rocky planets and the complex chemistry required for life. The atoms that make up your body were literally forged inside the cores of stars that lived, burned, and detonated billions of years before our solar system ever existed. Because of this unbreakable chain of physical processes, chemistry operates as a cosmic clock. The presence of heavy elements in a galaxy is absolute, undeniable proof that an entire generation of stars has already lived out its full lifespan and died. In astronomy, any element heavier than helium is broadly referred to as a metal, and tracking the metallicity of a galaxy is how scientists read its age. You cannot bypass the clock. A galaxy cannot fake its chemistry. If you detect heavy elements, you are looking at a system that has already endured immense stretches of time, multiple stellar life cycles, and widespread supernova activity. When astronomers point their telescopes at the local, present-day universe, they see galaxies rich with these heavy metals, the result of 13.8 billion years of continuous cosmic recycling. But when they used the James Webb Space Telescope to peer back into the deepest, oldest edges of the observable universe, the expectation was completely different. They were aiming their spectrographs at galaxies that existed mere hundreds of millions of years after the Big Bang. At this extreme distance, looking at the very dawn of structure formation, the models strictly dictated that they should find pristine, uncontaminated environments. They were fully prepared to see the raw, unprocessed hydrogen and helium left over from creation, perhaps illuminated by the very first, slow-burning stars. Instead, the spectrograph data returned a signature that shouldn't have been there. When the combined observations of the James Webb Space Telescope and the Atacama Large Millimeter Array analyzed the impossibly massive, impossibly early galaxy known as JADES-GS-Z14-0, they detected a glaring, unmistakable spectral emission line. They found oxygen. They detected oxygen sitting in a fully assembled galaxy that existed when the universe was precisely 290 million years old. To grasp the paralyzing fear this single chemical signature sends through the astrophysics community, you have to understand the excruciating compression of time it demands. In the timeline dictated by the standard model of cosmology, the universe at 290 million years old was supposed to be barely crawling out of the cosmic dark ages. The very first primitive stars were not expected to even begin igniting until the universe was somewhere between 100 and 200 million years old. If the first stars are only just turning on at the 200 million year mark, how can a massive, brightly burning galaxy exist at the 290 million year mark completely saturated with oxygen? For oxygen to be radiating from a galaxy at this epoch, the universe could not have taken its time. The entire agonizingly slow chain of cosmic creation had to have been drastically, violently compressed. In a span of time that is mathematically equivalent to a mere rounding error in the life of our own Milky Way, the infant universe had to gather primordial gas, ignite a first generation of stars, allow those stars to live out their entire lifespans, wait for them to detonate in catastrophic supernovas, allow the expelled oxygen to mix with the surrounding gas clouds, and then funnel that enriched gas into a second generation of stars massive enough to form a galaxy measuring 1,600 light-years across. The timeline of reality is uncomfortably, terrifyingly compressed. It is akin to excavating an ancient Roman ruin and finding a fully functioning smartphone buried among the stones. The technology of the universe is far too advanced for the era in which it is being found. Faced with this impossible chemistry, scientists are being forced to conjure monsters to make the math work. If the universe managed to forge oxygen this early, it means the first stars to exist could not have been normal. They must have been leviathans. Theorists refer to them as population 3 stars, but the term fails to capture their terrifying nature. Because these very first stars formed from the pure, uncontaminated hydrogen and helium of the Big Bang, without any heavy elements to help cool the collapsing gas clouds, they could not fragment into normal-sized stellar bodies. Instead, the gas collapsed into monolithic, supermassive structures. These population 3 monster stars are theorized to have weighed anywhere from 1,000 to 10,000 times the mass of our Sun. They would have been the most massive, violent, and intensely burning objects to ever exist. Because of their incomprehensible mass, their cores would have been pressurized to degrees we can barely model, forcing them to fuse elements at a furious runaway pace. While a star like our Sun will burn peacefully for 10 billion years, these primordial monsters would have consumed their entire fuel supply in a blinding flash of cosmic time, perhaps living for only a few million years before collapsing, and their deaths would have been equally absolute. They wouldn't have just exploded, they would have detonated as hypernovas, the most energetic explosions possible under the laws of physics, ripping themselves apart so violently that they spewed millions of Earth masses of newly forged oxygen, carbon, and nitrogen deep into the primordial dark. The detection of oxygen at 290 million years demands that entire generations of these theoretical monsters must have already lived, burned with terrifying intensity, and annihilated themselves before the universe was even 3% of its current age. The cosmos did not slowly wake up. It exploded into existence with a ferocity that threatens to break our understanding of how matter behaves, and the terror deepens because JADES-GS-Z14-0 is not an outlier. As the telescope sweeps across the sky, it is finding these impossible chemical signatures everywhere. It has detected carbon, nitrogen, and oxygen in multiple galaxies from the first few 100 million years of existence. In one bizarre object, researchers found an extreme, highly unusual ratio of nitrogen to oxygen, a chemical fingerprint that cannot be produced by normal stars or normal supernovas. The only mathematical model that matches this bizarre nitrogen spike is the direct exhaust of these population 3 monster stars, captured right before they detonated. We are looking at a universe that was operating under a completely different, hyper-accelerated set of rules. The standard model of cosmology, lambda cold dark matter, is built on the foundation of slow, hierarchical assembly. It demands patience. It demands that small halos of dark matter gather slowly, that gas cools gently, and that stars form at a measured, heavily regulated pace. The James Webb Space Telescope has stared directly into the cosmic dawn and found that the universe was not patient. It bypassed the speed limits of creation, forcing chemistry into existence in an impossibly compressed window. The paradox of these heavy elements is not just a curiosity for astrophysicists to debate at conferences, it is a fundamental warning. We have built our entire understanding of reality, our models of gravity, our timelines of evolution, and our equations of thermodynamics based on observing the cold, aging, slow-moving universe that surrounds us today. We assumed that the laws governing our quiet cosmic neighborhood were universal, But Webb has shown us that when the universe was young, it was perfectly capable of operating a machinery of creation so vastly overpowered that it forged the building blocks of life in a fraction of the time our physics allows. If our foundational model for how stars ignite and how heavy elements are forged is completely invalidated by the very first light we can measure, then we must accept a terrifying possibility. The rules of reality are not fixed. The timeline we constructed to explain our own existence is fundamentally flawed. We are a species desperately trying to read a clock that was built by a universe we do not actually understand, ticking at a speed that should be impossible. To truly comprehend the depth of the deception we are trapped inside, we must now pull our gaze away from the microscopic chemistry of ancient stars and the impossible feeding rates of individual black holes. We must stop looking at the isolated puzzle pieces and step back to examine the architecture of the board itself. When you stand outside on a clear night and look up at the sky, human intuition tells you that the universe is just an endlessly massive, empty container where stars and galaxies are scattered randomly, like dust thrown across a black floor. We are biologically wired to assume that if we travel far enough in any direction, we will simply encounter more of the same, more random galaxies, drifting aimlessly through an infinite, featureless void. But as the James Webb Space Telescope and its companion observatories have mapped the deepest regions of the cosmos, they have confirmed that this intuition is a complete illusion. Galaxies are not scattered randomly through space. They do not drift aimlessly in the dark. They cluster, they align, and they trace invisible, highly specific pathways across enormous distances. When you zoom out far enough, the universe stops looking like a loose collection of isolated objects and begins to resemble a vast, interconnected biological nervous system. This is the cosmic web, the largest coherent structure in existence. It spans the entire 93 billion light-year diameter of the observable universe, organizing everything we can see into a staggering three-dimensional foam. The architecture of this web is dictated not by the visible matter that shines, but by the dark matter that we cannot see. Dark matter, which outweighs normal matter by a factor of 5 to 1, provides the invisible scaffolding for reality itself. Shortly after the Big Bang, tiny quantum fluctuations in the density of the universe were amplified by gravity over hundreds of millions of years. Dark matter responded to these fluctuations first, quietly gathering into growing concentrations and forming massive, invisible filaments. These dark matter filaments stretch for tens to hundreds of millions of light-years across the void, acting as the structural beams of the cosmos. Ordinary matter, the hydrogen and helium gas that eventually became stars, planets, and human beings, simply followed this invisible blueprint. The gas pooled into the dark matter valleys, cooled, and ignited into galaxies exactly where the dark matter dictated they should. Today, galaxies flow along these cosmic highways, pulled continuously by gravity like rivers of starlight draining into massive cosmic ocean basins. Where multiple filaments intersect, matter piles up in unimaginable quantities, forming the bright, dense nodes of the web. These nodes are galaxy clusters, the most massive gravitationally bound objects in the universe, containing hundreds or thousands of galaxies violently interacting in a space just a few million light-years wide. But an architecture built on dense, interconnected threads demands the existence of something equally terrifying: the spaces left behind. Between the glowing filaments and the crowded intersections of the cosmic web lie the voids. These are enormous regions of space spanning tens to hundreds of millions of light-years in diameter, where structure formation simply failed to occur. Because gravity spent billions of years pulling matter outward into the dense filaments, these regions were progressively emptied out, leaving behind a near-perfect vacuum. If you were to place Earth in the center of a typical cosmic void, the surrounding emptiness would be so absolute that our astronomers wouldn't have even known other galaxies existed until the invention of deep space telescopes in the 1960s. This extreme, terrifying contrast, a universe constructed of hyperdense, chaotic filaments separated by unfathomable, desolate oceans of nothingness, presents a massive problem for the physicists trying to calculate the fundamental laws of reality. To mathematically define the universe, to calculate its precise age, to measure its exact rate of expansion, to map its total size, scientists require the universe to be predictable. You cannot build a single universal equation for cosmic expansion if the universe behaves completely differently depending on whether you are standing in a crowded galaxy cluster or floating in a dead void. To solve this problem and to make the math work, the entire field of modern cosmology relies on a single, foundational assumption. It is an assumption so deeply embedded in the bedrock of physics that it is rarely ever questioned. It was introduced by Albert Einstein himself when he applied his equations of general relativity to the universe as a whole, and it is known as the cosmological principle. The cosmological principle is a declaration of cosmic order. It states that at sufficiently large scales, the universe must be both homogeneous and isotropic. In simpler terms, it assumes that if you zoom out far enough, past the individual galaxies, past the dense clusters, and past the vast empty voids, the universe must eventually average out. It must become a smooth, uniform, featureless expanse, looking roughly identical in every direction from any vantage point. The extreme variations of the cosmic web are permitted to exist locally, but on the grandest scales, the universe is required to be essentially the same everywhere. This principle is not just a philosophical preference, it is the load-bearing pillar of modern science. It is the reason we can use the temperature of the cosmic microwave background to calculate a single global expansion rate for the entire cosmos. It is the foundation that allows the Hubble constant to be treated as a property of space itself, rather than a localized quirk of our specific neighborhood. Without the cosmological principle, the equations we use to define the 93 billion light-year scale of reality completely disintegrate. Because physics operates under strict speed limits, this principle carries a very specific mathematical requirement for the maximum permitted size of any structure in the cosmos. Gravity is the force responsible for building the cosmic web, but gravity moves at the speed of light. In a universe that has only existed for 13.8 billion years, there is an absolute hard limit on how far a gravitational signal could have traveled to pull matter together into a single, cohesive shape. Based on the laws of physics and the time available since the Big Bang, standard models dictate that no coherent structure in the universe should be larger than approximately 1.2 billion light-years across. Above that scale, gravity simply hasn't had enough time to organize matter, and the universe must dissolve into statistical uniformity. For decades, the math held up. But as our survey instruments grew more powerful, mapping deeper and wider swathes of the cosmos, disturbing cracks began to appear in this uniform picture. In 2003, astronomers mapping the distribution of galaxies discovered the Sloan Great Wall, a massive filamentary structure spanning approximately 1.37 billion light-years. It sat just barely above the theoretical limit. In 2016, the Boss Great Wall was identified, reaching roughly 1 billion light-years across. Recently, Webb detected the Cosmic Vine, a sprawling chain of galaxies reaching tens of millions of light-years long in the very early universe, forming far faster than the rules of gravity should allow. These were anomalies, uncomfortable outliers that strained the boundaries of the cosmological principle, but scientists hoped they were just extreme local variations that would ultimately be smoothed out by larger datasets. Then, astronomers stopped looking for faint galaxies and started looking for the most violent explosions in the cosmos. When massive stars die, they do not go quietly. Their core collapse can trigger a gamma-ray burst, an unfathomably powerful beam of high-energy radiation that can outshine the entire universe for a few fleeting seconds. Because they are the brightest electromagnetic events known to exist, gamma-ray bursts serve as the ultimate deep space beacons, allowing astronomers to detect the presence of matter at distances far beyond the reach of normal galaxy surveys. Since massive stars form in dense regions of gas and dust, tracking the locations of gamma-ray bursts is a way to map the underlying architecture of the cosmic web at the most extreme scales. In 2013, a team of researchers led by Istvan Horvath analyzed the distribution of these violent beacons across the sky. They expected to find them scattered relatively evenly, adhering to the smooth, uniform distribution demanded by the cosmological principle. Instead, they found a clustering of gamma-ray bursts that defied all mathematical logic. There was a concentration of mass so immense and so dense that it completely broke the equations of cosmic evolution. The scientific community was hesitant, demanding more data, assuming it was a statistical fluke. But in April 2025, an expanded, rigorous analysis using a much larger catalogue of bursts confirmed the detection with devastating statistical significance. They had not found a fluke, they had found a monster. They named it the Hercules Corona Borealis Great Wall, after the constellations its massive footprint spans in our night sky. It is a single, coherent wall of galaxies, gas, and dark matter that stretches across space for an unimaginable 10 billion light-years in length and roughly 7.2 billion light-years in width. To comprehend the terror of this measurement, you must compare it to the absolute limits of reality we discussed earlier. The entire observable universe, the absolute maximum boundary of everything humanity can ever see, defined by the speed of light over the course of 13.8 billion years, is 93 billion light-years across. The Hercules Corona Borealis Great Wall is 10 billion light-years long. That means this single, continuous structure spans more than 10% of the diameter of the entire observable cosmos. If the observable universe were the size of a vast, sprawling city, this is not a large building. This is a monolithic, unbroken wall of concrete stretching across the entire width of Manhattan. Under the strict laws of modern physics, this structure is completely impossible. The theoretical speed limit for the largest allowed coherent structure is 1.2 billion light-years. The Hercules Corona Borealis Great Wall is more than 8 times too large to legally exist. Gravity has simply not had enough time since the Big Bang to communicate across a distance of 10 billion light-years, let alone organize that much matter into a single, cohesive, filamentary wall. There is absolutely no physical mechanism within the standard model of cosmology that can produce a structure of this magnitude, and yet it is there. The gamma-ray bursts trace its massive, impossible outline in the dark. The existence of the Hercules Corona Borealis Great Wall forces an apocalyptic crisis in the field of astrophysics. It is not a minor anomaly that can be patched with a new variable or a slight adjustment to the equations. Its sheer size guarantees that the universe does not smooth out. It does not average into a featureless, uniform expanse. It exceeds the homogeneity limit by such a terrifying margin that accommodating it requires either completely overhauling our entire understanding of how matter behaves or accepting a much darker truth. The cosmological principle is dead. Albert Einstein's foundational assumption, the very bedrock upon which every modern equation of cosmic evolution is built, is fundamentally incorrect. The universe is not homogeneous, it is not isotropic. The rules do not apply evenly across the board. And the terror of this realization is not just philosophical, it cascades down into every single measurement we have ever made about the reality we inhabit. If the universe is not uniform, then the math we use to define the universe's scale is entirely invalid. We use the cosmic microwave background to calculate a global expansion rate because we assume the universe expands evenly in all directions. But if the cosmos is choked with lopsided 10 billion light-year wide walls of hyperdense matter on one side and unfathomably large voids on the other, then gravity is pulling unevenly across the expanse. The rate at which space is stretching here might be entirely different from the rate at which space is stretching there. That means the comforting number we opened with, the 93 billion light-year diameter of the observable universe, might be nothing more than a localized illusion derived from a broken formula. The James Webb Space Telescope and its massive survey programs have confirmed that the largest structures in the cosmos are blatantly violating the mathematical models we use to comprehend them. The math is not just slightly off, it is structurally compromised from the ground up. We are a species desperately trying to measure the dimensions of a house using a ruler that is actively bending, stretching, and warping depending on which room we are standing in. We have scaled out to the largest perspective humanity is capable of achieving, and the universe has responded by proving that our foundational maps are drawn on an architecture we do not understand. The cosmological principle was a safety blanket, a way to impose human logic and mathematical symmetry onto an unfathomable abyss. Now that blanket has been violently ripped away, leaving us exposed to a cosmos that is drastically more unpredictable and hostile to our equations than we ever feared. But the horror of our broken vantage point does not stop at the distant edges of the Hercules Corona Borealis Great Wall. If the geometry of the entire universe is skewed by uneven distribution, we must eventually look down at our own feet. We must ask where exactly we are standing within this chaotic, lopsided web. And as we will discover in the next chapter, our specific address in the cosmos is not just ordinary. We are trapped inside a massive gravitational anomaly of our own, observing reality from inside a funhouse mirror that may be systematically blinding us to the truth. For centuries, every major revolution in astronomy has been built upon a single, humbling demotion: the realization that there is absolutely nothing special about our location in the universe. We learned that Earth does not sit at the center of the solar system, that our sun does not sit at the center of the galaxy, and that the Milky Way is just an ordinary system adrift among trillions of others. This principle of mediocrity is the bedrock of modern science. It allows us to believe that the physical laws we measure in our small local patch of space apply evenly to the rest of the infinite cosmos. We assume that our window to the universe is made of clear, perfect glass. But the James Webb Space Telescope has forced us to confront a terrifying possibility. What if our window is fundamentally warped? What if the very fabric of space surrounding our solar system is a localized anomaly, actively distorting the light that reaches us? We are not just a small species peering into a vast abyss. We might be trapped inside a massive, invisible funhouse mirror that is systematically blinding us to the true scale of reality. The realization that our vantage point is broken begins with a crisis that has quietly haunted the astrophysics community for nearly a decade, a crisis that has recently erupted into full-blown panic. It centers around a single number known as the Hubble constant. This is arguably the most important number in all of cosmology, representing the exact rate at which the universe is currently expanding. Knowing this precise speed is how we calculate the age of the cosmos, how we map the 93 billion light-year boundary of the observable universe, and how we predict the ultimate fate of reality itself. Determining the Hubble constant with absolute precision has been the primary obsession of observational astronomy for 30 years. To find it, scientists use the two most powerful, precise measuring methods humanity has ever developed. The problem is that these two methods are returning two completely different answers, and neither of them can mathematically be wrong. The first method involves looking as far back into time as physics allows, measuring the expansion rate of the early universe. To do this, astronomers study the cosmic microwave background radiation. This is the faint, fading afterglow of the Big Bang, a wall of ancient microwave light that fills the entire cosmos, released when the universe was just 380,000 years old. By analyzing the microscopic variations and temperature fluctuations in this ancient radiation, physicists can read the density and acoustic waves of the infant cosmos. From these primordial patterns, measured with exquisite precision by instruments like the Planck satellite, they can run the standard model of cosmic evolution forward like a computer simulation to predict exactly how fast the universe should be expanding today. This incredibly precise, mathematically rigorous method yields an expansion rate of approximately 67 kilometers per second per megaparsec. The second method ignores the ancient past and measures the expansion rate of the local universe directly, right now. Astronomers build what is known as a cosmic distance ladder. They start by measuring the exact distances to nearby pulsating stars, called Cepheid variables, and then extend that measurement outward to violently detonating stars, called Type 1a supernovas, in distant galaxies. Because these supernovas explode with a highly consistent, predictable brightness, they act as cosmic mile markers. By comparing how bright they appear to how bright we know they actually are, we can determine their exact distance. Then, by analyzing how much their light has been stretched by the expansion of space, we can see exactly how fast they are moving away from us. When astronomers use this direct physical measurement of the local universe, refining the data over decades of observation, the answer comes out to approximately 73 kilometers per second per megaparsec, 67 versus 73. To a casual observer, the gap between those two numbers might sound like a trivial rounding error. In the unforgiving, hyper-precise realm of cosmology, it is an apocalyptic failure. Both of these measurements have been refined, repeated, and verified over decades by independent teams of the most brilliant minds on Earth. Yet the gap between them refuses to close. In statistical terms, physicists express the severity of a discrepancy in standard deviations, or sigma. The disagreement between the early universe measurement and the local universe measurement stands at a devastating 5 to 6 sigma. To put that into perspective, in the field of particle physics, a 5 sigma result is the strict threshold required to announce the confirmed discovery of a new fundamental particle. It represents a 1 in a million chance of being a random statistical fluke. The discrepancy is not a mistake, it is an undeniable, glaring contradiction in the physical behavior of reality. Astronomers named this crisis the Hubble tension. For years, the scientific community clung to a desperate, comforting hope. They told themselves that the models weren't broken, but rather that the instruments were flawed. The local measurements heavily relied on the Hubble Space Telescope, an extraordinary but aging observatory. The assumption was that Hubble's sensors were introducing a subtle, systematic calibration error into the distance ladder, perhaps crowding Cepheid variable stars together and misreading their light. They prayed that when the James Webb Space Telescope finally launched, its revolutionary infrared sensors and unmatched resolution would correct the error, proving that the local expansion rate actually matched the early universe, and saving the standard model from collapse. In 2023, that hope was violently extinguished. When Webb aimed its 21-foot golden mirrors at the exact same key-feed variables and supernovas used in the previous measurements, it did not find an error. The new telescope confirmed the Hubble Space Telescope measurements with terrifying precision. The instruments are not flawed. The Hubble tension is absolutely real. Our two most precise methods of reading the universe are telling us contradictory things, and neither can be wrong in a simple, fixable way. If the telescopes are working perfectly and the math governing the cosmic microwave background is sound, then we are left with a terrifying conclusion. The discrepancy is not an error in how we are looking. The discrepancy is caused by where we are standing. To understand why our specific location in the universe is corrupting our perception of scale, we must return to the architecture of the cosmic web. As we established, the universe is not a uniform ocean of stars. It is an intricate, lopsided network of hyperdense dark matter filaments separated by staggering oceans of emptiness known as voids. These voids are the largest structures in the cosmos by volume, vast regions spanning tens to hundreds of millions of light-years where matter simply failed to gather. To grasp the extreme nature of these dead zones, consider the famous Bootes void. Discovered in 1981, this desolate region measures an astonishing 330 million light-years in diameter. In a normal region of the universe, a space that size should contain many thousands of galaxies. The Bootes void contains approximately 60. It has been progressively emptied out over billions of years, its matter pulled away by the gravitational attraction of the dense filaments surrounding it. The scale of this emptiness is so profound that if our solar system were placed in the dead center of the Bootes void, the night sky would be completely devoid of other galaxies. Human astronomers would not have even known that anything existed outside our own star system until the invention of deep space telescopes in the 1960s. We would have lived our entire history believing the universe consisted of a single, isolated island of stars drifting in infinite darkness. The existence of extreme voids proves that your physical location within the cosmic web completely determines your picture of reality. For centuries, we have based our physics on the assumption that our solar system resides in an average, typical, heavily populated region of the cosmos. But deep, large-scale mapping of the local universe has quietly assembled evidence for a reality that is vastly more disturbing. We do not live in an average region of space. We are trapped inside a massive gravitational anomaly of our own. We appear to live inside a void. This structure is known as the KBC void, named after the three researchers, Keenan, Barger, and Cowie, who systematically characterized it. The KBC void is an enormous, drastically underdense region of space where the average density of matter is substantially lower than the cosmic mean. But the true horror of the KBC void is its incomprehensible size. The Bootes void, a structure so unfathomably large that it embarrassed its discoverers, spans 330 million light-years. The KBC void is 6 times larger. It is a spherical bubble of emptiness measuring a staggering 2 billion light-years across. It encompasses not just the Milky Way but our entire local group of galaxies, the massive Laniakea supercluster with its 100,000 galaxies and several hundred million light-years of surrounding space in every single direction. We are not just drifting near the edge of this anomaly. Our solar system is located roughly within its interior. Living inside a 2 billion light-year wide bubble of emptiness is not just a fascinating trivia fact about our cosmic address. It is a physical circumstance with catastrophic consequences for our understanding of reality, and it provides the terrifying mechanism behind the Hubble tension. Gravity is not just a force that pulls matter together, it is a force that dictates the flow of space itself. In a universe governed by the cosmic web, regions of lower than average density experience completely different gravitational dynamics than the rest of the cosmos. Because the interior of the KBC void contains significantly less matter than average, it lacks the gravitational strength to hold on to the galaxies inside it. Instead, the overwhelming mass of the dense, crowded filaments forming the walls of the void actively pulls the matter outward. As this massive void slowly expands and empties over billions of years, every galaxy trapped inside it is physically dragged toward the dense edges. This gravitational tug-of-war imprints an additional, artificial outward velocity onto the motion of everything in our local neighborhood. When astronomers use the distance ladder to measure the expansion rate of the local universe, they are observing galaxies that are being actively ripped outward by the walls of the KBC void. Our local gravity pushes outward differently, artificially boosting the speed at which nearby galaxies appear to be receding. We are measuring an accelerated local flow and mistakenly interpreting it as the universal expansion rate of space itself. The terrifying synthesis of the Hubble tension and the KBC void is the realization that our entire measurement of the universe's scale is a local illusion. The James Webb Space Telescope did not just prove that the early universe is older and more crowded than we thought. By confirming the Hubble tension, it proved that we are observing the cosmos from a broken vantage point. We are measuring the infinite expanse of reality from inside a 2 billion light-year wide funhouse mirror. The bubble we live in is actively warping the velocities, the distances, and the light of everything we use to calculate the laws of physics. If the expansion rate measured in our local universe is artificially inflated by the gravitational distortion of the KBC void, then the fundamental math we use to define the true scale of the universe is systematically compromised. We proudly state that the observable universe is exactly 93 billion light-years across, assuming that the expansion of space behaves uniformly in all directions at all times. But if our measuring stick is actively bending and stretching because of the empty bubble we inhabit, then that 93 billion light-year diameter might be a massive overestimation or a severe underestimation of what is actually out there. The true scale of reality is deeply misunderstood, permanently shielded from our view, because our local physics is essentially a localized distortion. We are a species that has spent its entire intellectual history staring out a window, carefully drawing maps of the cosmic terrain, only to discover that the glass we are looking through is curved, defective, and lying to us. The James Webb Space Telescope has stripped away our comforting assumption of a uniform, measurable cosmos. It has shown us that the universe is perfectly capable of hiding its true nature behind local gravitational illusions. But the terror of our situation does not end with a warped measuring tape, because as we look beyond the walls of our empty local bubble, we are finding evidence that the force driving this cosmic expansion, the very dark energy of the universe, is not just deceiving us. It is actively mutating, and its shifting nature threatens to tear apart the fundamental forces of reality itself. If the massive void we inhabit is actively warping our local measurements of space, it forces us to confront a much larger and far more dangerous mechanism operating behind the scenes. To understand the true scale of the deception we are trapped inside, we must look at the engine driving the universe apart. We must examine the invisible force that is not merely stretching the cosmos, but actively rewriting the fundamental laws of physics as it goes. For the entirety of human history, we believed that the forces of nature were fixed. We assumed that gravity, electromagnetism, and the laws of thermodynamics operated today exactly as they did at the dawn of time, and exactly as they will a trillion years from now. But recent data has revealed a terrifying truth. The operating system of the universe is not stable. The fundamental forces of reality are shifting, and we are currently living through the fallout of a massive cosmic flip. To comprehend this shift, we must first define the invisible ocean we are drowning in. In 1998, astronomers studying distant, violently detonating supernovas made a discovery that shattered the foundational assumptions of cosmology. Until that moment, the scientific consensus held a very logical belief about the future of the universe. The Big Bang had set everything into outward motion, but because the universe is filled with matter, the collective inward pull of gravity should have been acting as a cosmic brake. The expansion of space was supposed to be slowing down. Instead, the supernova data revealed the exact opposite. The distant galaxies were farther away than they should have been. The expansion of the universe was not slowing down, it was accelerating. Something in the dark was actively pushing space apart, overpowering the combined gravitational pull of every star, planet, and black hole in existence. Lacking a physical explanation for what this repulsive force actually was, cosmologists gave it a placeholder name, dark energy. The name sounds like a minor, exotic phenomenon, but its sheer volume makes it the absolute dictator of reality. When astrophysicists mapped the total energy budget of the cosmos, the numbers were profoundly humbling. Ordinary matter, every single thing that has ever been seen, touched, measured, or modeled in the entire history of human science, including all the galaxies, stars, and planets, makes up a mere 5% of the universe. Dark matter, the invisible scaffolding holding galaxies together, makes up roughly 27%. Dark energy comprises the remaining 68% of everything in existence. It is the dominant component of reality. Yet it has no physical description. It does not shine, it does not absorb light, and it does not clump together. It is an invisible, repulsive pressure inherent to space itself, and we have absolutely no idea what it actually is. Because dark energy is so entirely alien to our understanding of physics, scientists desperately needed to confine it within a predictable mathematical box. They relied on the simplest possible explanation, a concept originally introduced by Albert Einstein in 1917 known as the cosmological constant. In this model, dark energy is a fixed, unchanging property of empty space. It has a specific, unvarying density that never weakens or strengthens. As the universe expands and creates more empty space, more dark energy comes into existence, maintaining exactly the same repulsive force per cubic meter, regardless of when or where in the universe you measure it. This assumption of a constant, stable dark energy became the bedrock of modern physics. It allowed cosmologists to predict the exact fate of the universe. If dark energy is a constant, it will simply continue to push galaxies apart at a steady, accelerating rate forever, leading to a quiet, cold, infinite expansion. For nearly 30 years, we treated this constant as a universal law. Then on April 4, 2024, the Dark Energy Spectroscopic Instrument, or DESI, released the results of its first year of observations. Mounted on a telescope in Arizona, DESI had spent a year measuring the precise redshifts of over 6 million galaxies, constructing the most detailed three-dimensional map of the universe's large-scale structure ever assembled. Its primary mission was to test the cosmological constant, to look back through cosmic time and verify that dark energy has always behaved with the exact same, unchanging strength. When the DESI collaboration combined their massive new dataset with measurements from the Planck satellite and other supernova surveys, the results triggered an immediate crisis. The data did not show a constant. It showed a deviation from the cosmological constant at a statistical significance of 3.9 sigma. In the strict, unforgiving realm of astrophysics, this translates to an extraordinarily high confidence that the fundamental behavior of dark energy has changed over the history of the universe. The director of the DESI project stated it plainly. The data raised the terrifying possibility that dark energy is evolving. Separate analyses of the data suggested that this force, which makes up 68% of reality, may have decreased in strength by roughly 10% over recent cosmic history. If dark energy is not a constant property of empty space, if it can mutate, weaken, or strengthen as the universe ages, then every single prediction we have ever made about the scale and the fate of the cosmos is suddenly void. But the true terror of the DESI data is not just that dark energy is changing, it is how it changed. To understand the horrifying implications of this mutating force, we must look at a specific mathematical parameter that physicists use to define it, known as the equation of state. The equation of state, typically written as the letter W, describes the relationship between dark energy's pressure and its density. If dark energy is exactly equal to Einstein's cosmological constant, the value of W is perfectly locked at -1. If W sits anywhere above -1, it describes a dark energy that slowly dilutes and weakens as the universe expands, potentially allowing gravity to one day regain control. But if the value of W drops below -1, it enters a realm of physics that is mathematically terrifying. Physicists have a specific name for dark energy that operates below this threshold: phantom energy. Phantom energy violates our most basic intuition about how the physical world works. In a normal universe, as space expands, the energy inside it should dilute. But phantom energy grows stronger as the universe expands. The more space there is, the more dense and powerful the phantom energy becomes, pushing outward with an aggressively multiplying force. It creates an infinite runaway feedback loop. If the universe is governed by phantom energy, the expansion accelerates without any limit. The repulsive force will eventually grow so violently powerful that it overcomes every other force in nature. It will rip apart galaxy clusters, then individual galaxies, then solar systems, then planets, and eventually the atomic bonds holding matter itself together. Under the standard, comforting models of cosmology, dark energy is strictly forbidden from crossing this threshold. A cosmological constant sits at exactly -1 and stays there forever. But when researchers analyzed the 2024 DESI data, they found evidence for something that standard theoretical frameworks say is entirely impossible. The data indicated that dark energy's equation of state had actually crossed the phantom divide. The measurements suggest that in the deep cosmic past, dark energy behaved as phantom energy, with a W value dropping below -1, but it has since mutated, weakened, and currently sits above that threshold. The fundamental operating system of the universe did something its simplest descriptions forbid it to do. This revelation is the ultimate synthesis of the terror uncovered by the James Webb Space Telescope. By combining the impossible early galaxies found by Webb with the mutating dark energy found by DESI, we expose a massive, ignored law gap in our understanding of reality. The fundamental forces of physics have flipped. Let us look back at the fossils of the cosmic dawn that Webb uncovered. We saw the universe-breaker galaxies, massive, fully formed metropolises of stars existing just a few 100 million years after the Big Bang. We saw the little red dots, ancient systems harboring supermassive black holes that vastly outweighed their host galaxies, feeding at 40 times the absolute physical speed limit. We saw the Hercules Corona Borealis Great Wall, a structure spanning 10 billion light-years, forged in an era when gravity shouldn't have had the time to communicate across a fraction of that distance. The standard model of cosmology demanded a slow, patient assembly, but the early universe we actually observe was a place of ferocious, hyper-efficient creation. Gravity, the oldest force in cosmological reckoning, was operating at an intensity and an efficiency that defies all modern equations. It gathered incomprehensible oceans of gas, collapsed dark matter halos, and built impossible structures almost instantly. The universe began its life dominated by a form of gravity so potent it practically bypassed the speed limits of thermodynamics. But that is not the universe we live in today. Today, the universe is ruled by a mutating, evolving phantom energy. The hyper-efficient gravity that built the cosmic web and forged the first galaxies has been entirely overpowered. The cosmos flipped from a tightly bound, gravity-dominated engine of rapid creation into a runaway, dark, energy-dominated void of accelerating expansion. The terrifying reality is that the laws of physics are not stable across the scale of time. We have spent centuries cataloging the physical laws of our local, present-day environment, assuming they were the eternal, unchanging bedrock of existence. We believed that if we just looked far enough, the universe would smoothly reveal its history according to these fixed rules. But the universe is actively deceiving us. It is changing its own parameters. We are trapped inside a 2 billion light-year-wide void that distorts our local measurements of expansion. We are looking back at a cosmic dawn built by an overpowered, hyper-efficient gravity we cannot mathematically explain. And we are being pushed into the future by a phantom energy that makes up 68% of reality, yet mutates and crosses forbidden physical boundaries at will. We are a species that has existed for a mere fraction of a cosmic second, attempting to decode a universe that refuses to keep its own rules straight. And as this dynamic, unstable dark energy continues to stretch the fabric of reality, it is enacting a process far more sinister than simply pushing galaxies apart. The changing scale of the universe is not just making the cosmos larger. It is weaponizing space itself to permanently erase the evidence of its own history, ensuring that future civilizations will be born entirely blind to the true nature of the abyss. We have uncovered the chaotic, violent dawn of creation, and we have stared into the mutating phantom energy that drives the modern cosmos. But the most profound terror revealed by the scale of the universe is not what it is doing to the galaxies, the dark matter, or the black holes. The most profound terror is what the universe is actively doing to us. When you look up at the night sky, you are experiencing an illusion of permanence. Human intuition tells us that the universe is a stable archive, a vast museum of stars and galaxies that will remain on display for any civilization possessing a telescope powerful enough to see them. We believe that the history of reality is safely recorded in the light traveling across the void. But the James Webb Space Telescope and the cosmological models it is actively testing confirm a truth that is deeply, fundamentally hostile to the existence of knowledge itself. The universe is not a museum. It is an actively self-deleting hard drive, and the scale of the cosmos is actively working to permanently blind us. To comprehend the mechanics of this great erasure, we must return to the invisible force dominating 68% of reality: dark energy. We have established that dark energy is causing the expansion of the universe to accelerate, pushing galaxies apart at an ever-increasing rate. But to understand the true horror of this acceleration, you have to follow the math to its inevitable, absolute conclusion. There is a hard, unbreakable speed limit within the universe, the speed of light, which travels at approximately 186,000 miles per second. Nothing can travel faster than this limit through space. However, this speed limit applies only to objects moving through the fabric of space. It does not apply to the fabric of space itself. Because the universe expands by stretching the empty space between objects, the cumulative expansion across vast distances can easily outpace the speed of light. If you look far enough out into the deep cosmos, the sheer volume of expanding space between Earth and a distant galaxy grows so rapidly that the distance between us increases faster than light can travel. When a galaxy is pushed away from us at a recession velocity that exceeds the speed of light, it crosses a terrifying mathematical boundary. it crosses the cosmic event horizon. The cosmic horizon is not a physical wall, a solid barrier, or an edge where space simply drops off into nothingness. The universe almost certainly continues far beyond it, filled with the same dark matter filaments, galaxy clusters, and ancient stars that populate our local neighborhood. Instead, the cosmic horizon is a boundary of information, a one-way membrane of causality. Once a galaxy is carried across this threshold by the accelerating expansion of space, it is permanently severed from our reality. Any light that galaxy emits today or tomorrow or 1 billion years from now will never reach Earth. The photons will be fired into the void, traveling at the maximum speed the laws of physics allow, but the space stretching beneath them will pull them backward faster than they can swim forward. It is like a runner sprinting at full speed on a treadmill that is accelerating backward endlessly. The light will never arrive, and the objects that emitted it might as well exist in a completely separate, alternate universe for all the influence they will ever have on ours. This is not a hypothetical scenario reserved for the distant future. This erasure is happening right now, continuously with every passing second. At this exact moment, galaxies are slipping across the cosmic event horizon. We are losing pieces of reality, entire island universes containing billions of stars, countless planets, and potentially entire civilizations, severed from our observable bubble forever. When the James Webb Space Telescope captures the faint infrared smudge of a galaxy sitting 30 billion light-years away, we are looking at a ghost in the truest sense. Because of the accelerating expansion of the cosmos, that physical galaxy has likely already been swept across the event horizon. We are merely receiving the ancient light it mailed to us billions of years ago, before the expansion rate between us became insurmountable. Once this final batch of ancient light finishes crashing into our telescopes, those galaxies will go dark, fading into a permanent, unreachable silence. But the terror of the cosmic horizon goes far beyond the steady, invisible loss of distant galaxies. The true nightmare of the scale of the universe is the timeline of its ultimate conclusion. If we project the current measured rate of dark energy's acceleration forward, the math delivers a brutally specific deadline for the end of observational astronomy. In approximately 100 to 150 billion years, the accelerating expansion of space will become so violently pronounced that the cosmic horizon will shrink inward, closing like a black curtain around our local neighborhood. Gravity is a powerful force, but its reach is limited. The mutual gravitational attraction between the Milky Way, the Andromeda Galaxy, and the few dozen smaller dwarf galaxies in our immediate vicinity is currently strong enough to resist the outward pull of dark energy. In a few billion years, our local group of galaxies will physically collide and merge into a single, massive, elliptical supergalaxy. But gravity's protection ends there. Every single object outside of our gravitationally bound local group, every distant quasar, every massive galaxy cluster, every filament of the cosmic web will be overpowered by the stretching of space. In roughly 100 billion years, every single galaxy beyond our merged local group remnant will be forced across the cosmic event horizon. They will not be destroyed, but they will be completely erased from the sky. As they cross the threshold, the extreme stretching of space will pull their light into infinitely long wavelengths, diluting their photons until they are entirely undetectable by any physical instrument, no matter how sophisticated. They will redshift into absolute nothingness. The trillion galaxies currently catalogued, measured, and marveled at by our observatories will vanish as if they had never existed at all. To truly feel the weight of this impending erasure, you must imagine the plight of a future civilization born on a planet orbiting a new star within that merged supergalaxy 100 billion years from today. Imagine a species of intelligent beings looking up at their night sky, just as our ancestors did, driven by the exact same curiosity to understand the cosmos they inhabit. When they build their first optical telescopes and sweep them across the darkness, they will see stars. They will see the billions of stars comprising their own massive elliptical galaxy. But when they build their own equivalent of the James Webb Space Telescope and aim its golden mirrors into the deep void beyond their galactic borders, expecting to find the architecture of the wider universe, they will find absolutely nothing. The deep fields will be empty. There will be no glowing red dots, no universe-breaking primordial galaxies, and no sprawling cosmic web. The universe will present itself to them as a vast, infinite ocean of pitch-black nothingness surrounding their single, lonely island of stars. But the deception goes much deeper than an empty sky. Because the universe is actively deleting its own history, it is also deleting the foundational evidence required to understand physics. Today, the ultimate proof of the Big Bang and the expanding universe is the cosmic microwave background, the faint, pervasive wall of radiation left over from the initial fires of creation. We tune our radio telescopes to it, we map its temperature fluctuations, and we read the story of the universe's birth. But in 100 billion years, the accelerating expansion of space will have stretched the wavelengths of the cosmic microwave background so drastically that the radiation will become entirely undetectable. The energy of the Big Bang's afterglow will be diluted to a fraction of a degree above absolute zero, its signal rendered effectively invisible to any possible antenna. Furthermore, because there will be no distant galaxies visible in their sky, these future astronomers will have absolutely no objects to measure. Without distant galaxies, there is no redshift. Without redshift, there is absolutely no evidence that space is expanding. When the greatest scientific minds of this future civilization gather to analyze the sum total of their cosmological data, they will apply the scientific method flawlessly. They will rely on precise observations, rigorous mathematics, and the undeniable evidence presented by their instruments. And based entirely on the flawless application of science, they will arrive at a conclusion that is absolutely, definitively wrong. They will look at their dark, empty sky and scientifically conclude that the universe consists of a single, isolated galaxy of stars drifting permanently in an endless, static, and unchanging void. They will believe with absolute certainty that the universe has no beginning, no expanding edge, and no wider architecture. The entire conceptual history of cosmology, from Edwin Hubble's discovery of the expanding universe to the James Webb Space Telescope's mapping of the cosmic dawn, will be permanently unavailable to them, impossible to reconstruct from the scrubbed, sanitized evidence left behind. The universe will have successfully executed the perfect crime. It will have hidden its origins, erased its structure, and locked its inhabitants inside a conceptual prison from which no amount of scientific inquiry can ever free them. This is the profound, chilling truth hiding behind the stunning images captured by our telescopes. We are not merely looking at ancient light. We are looking at temporary light. The staggering reality is that we just so happen to live in the exact brief and incredibly lucky window of cosmic time where the universe's scale is actually visible before it deletes its own history. The universe is estimated to exist for at minimum tens of billions, if not hundreds of trillions of years. Yet, the interval during which the complete history of cosmic evolution is legible, from the primordial quantum fluctuations to the cosmic microwave background, all the way to the oldest galaxies, is restricted to a narrow band of time spanning just a few billion years. We arrived late to the cosmic party, but we arrived right before the doors are permanently sealed shut. We evolved the intelligence to build glass lenses and golden mirrors in the exact, fleeting epoch where the evidence is still traveling across the void, just before the accelerating expansion of dark energy pushes the truth forever out of reach. The James Webb Space Telescope was not simply launched into space, it was launched into the twilight of comprehensibility. It arrived at the beginning of the last era in which it is possible to read the universe's full history. No civilization arising after this window closes will ever have the evidence needed to understand what came before them. What we know right now, what we are cataloging and mapping with frantic urgency, is something that will not always be knowable. The terror of the universe is not just its incomprehensible size, it is the realization that the scale of the cosmos is an active, erasing force. The universe is expanding so aggressively that it is actively blinding us, shutting down the horizons of information and preparing to leave whatever survives in a state of permanent, inescapable ignorance. We are staring into an abyss that is actively pulling the curtains closed, reminding us that the vast, terrifying architecture of reality we see today is a privilege that the universe will soon revoke. And as the evidence of our past is slowly deleted from the sky, we are left to wonder what other truths have already slipped beyond the horizon and what unimaginable fate awaits the reality that remains. We have watched the cosmic horizon close in, steadily deleting the evidence of the universe's past, but the erasure of history is only the prelude to a much darker and more absolute final act. To understand how the story of reality ultimately concludes, we must confront the final consequence of our broken physics. For nearly 30 years, the scientific community enjoyed a rare and comforting period of absolute consensus regarding the fate of the cosmos. Following the groundbreaking 1998 discovery that the expansion of the universe was accelerating, cosmologists settled into a single, universally accepted narrative. They believed they had successfully read the final chapter of existence, assuming that the dark energy driving the universe apart was a stable, unchanging cosmological constant. Under this assumption, we believed we knew exactly how the apocalypse would unfold. But as the James Webb Space Telescope and the precision measurements from the Dark Energy Spectroscopic Instrument have violently demonstrated, our foundational models are structurally fractured. The operating system of the universe is not stable. Dark energy, the invisible force comprising 68% of all reality, is not a fixed property of empty space. It is dynamic, it is mutating, and its behavior across the scale of time is wildly unpredictable. Because our physics is broken at this fundamental level, the 30 years of scientific consensus have completely dissolved. We are forced to realize that the terrifying scale of the universe, coupled with our profound misunderstanding of its core forces, means we are now completely blind to which apocalypse is coming. Our fractured models now permit three absolute, mathematically valid endings, each sitting before modern cosmology with roughly equal scientific standing. We are forced to choose our destruction from three scenarios of total annihilation, and the first permitted ending is the one we have feared the longest, the Big Freeze, sometimes referred to as the long cold death of heat entropy. This is the fate that awaits us if dark energy manages to hold steady or if it weakens too slowly for gravity to ever regain control. In this scenario, the universe simply continues to expand, pushing galaxies apart endlessly into the infinite void. As we have already seen, within the next 100 billion years, the accelerating expansion of space will drag every single galaxy outside of our local group permanently across the cosmic event horizon. But that erasure is only the beginning of a much deeper, unimaginable silence. Over the next 100 trillion years, the universe will slowly and agonizingly suffocate. The few galaxies that remain bound together will gradually consume their available gas, and the fierce engines of star formation will permanently shut down. The brilliant, burning stars that illuminate the cosmos today will exhaust their nuclear fuel, cool, and go dark. The mighty merged remnant of the Milky Way and Andromeda galaxies will devolve into a vast, ghostly cloud of cooling stellar corpses, faint white dwarfs radiating their final, residual heat into an ever-expanding abyss. But the Big Freeze does not stop at the death of stars. If the grand unified theories of particle physics are correct, even the fundamental building blocks of matter are not eternal. Over time, scales of roughly 10 raised to the power of 33 years, the very protons making up the dead stars and frozen planets will undergo radioactive decay, dissolving into light and subatomic particles. After the protons decay, the only structured objects remaining in the entire cosmos will be the supermassive black holes sitting in the centers of dead galaxies. Yet even they are not immortal. Through a quantum mechanical process known as Hawking radiation, these black holes will slowly evaporate, leaking their mass away over timescales approaching 10 raised to the power of 100 years. After the last black hole detonates in a final silent flash of radiation, what remains will be an infinitely expanding void containing only the faintest, most dilute traces of thermal energy. The universe will reach a state of maximum entropy. No further change will be physically possible, and the very concept of temperature will lose all meaning. This cold, featureless state will persist forever, because forever is literally all that remains. However, the 2024 DESI data introduced a second, far more violent apocalypse. If dark energy's equation of state crosses the phantom divide, dropping below a value of -1, it transforms into phantom energy. This force violates our basic intuition of physics. It does not just push galaxies apart, it grows exponentially stronger and denser as the universe expands, feeding on the very space it creates. If the universe is ruled by this mutating runaway force, we face the absolute horror of the Big Rip. In this scenario, the phantom dark energy accelerates infinitely, creating a repulsive force so violently powerful that it systematically overwhelms every binding force in nature. The timeline of the Big Rip is a mathematically precise countdown to total subatomic dismemberment. Approximately 2 billion years before the end of the universe, the phantom energy will grow strong enough to sever the gravitational bonds holding massive galaxy clusters together. The great nodes of the cosmic web will dissolve into isolated, drifting galaxies. Then, 60 million years before the end, the repulsive force will overpower the gravity of the Milky Way itself, tearing our galaxy apart and scattering its stars into the void. The apocalypse then accelerates terrifyingly toward the microscopic scale. Just 3 months before the final moment, the phantom energy will overcome the gravitational pull of our sun, ripping our planetary system apart and sending Earth drifting blindly into space. 30 minutes before the end, the physical structure of Earth itself will be pulled into fragments. And then in the last fractions of a second, the universe will accelerate through chemistry and physics. The phantom dark energy will become stronger than the strong nuclear force, and atoms themselves will be violently ripped apart. The universe will not end in a quiet, fading silence. It will end in the violent dismemberment of absolutely everything that exists, as space itself tears reality to shreds. And yet there is a third ending, one that completely reverses the trajectory of the cosmos, returning us to the violent singularity from which we came. In September 2025, physicist Henry Tai published a groundbreaking paper in the Journal of Cosmology and Astroparticle Physics, suggesting a fate that defies both the endless freeze and the violent rip. Tai's analysis focused on the cosmological constant itself, proposing that the supposed fixed energy of empty space might actually be a metastable state. At its deepest, fundamental level, the mathematical value of this constant may effectively be negative. If this is true, the current phase of accelerating expansion is nothing more than a temporary illusion. Gravity will eventually win the cosmic tug-of-war, leading to the devastating collapse known as the Big Crunch. The timeline Tai's models produce is brutally specific. Our universe is currently 13.8 billion years old. Tai calculates the total lifespan of the universe at roughly 33 billion years. This means the current, accelerating expansion we observe today will only continue for approximately 11 more billion years. After that, the expansion halts. A contraction phase will begin, initiated by a subtle, barely detectable deceleration in the cosmic expansion rate. Galaxies that have been drifting apart for billions of years will slow down, stop, and then begin to approach one another. Over time, scales comparable to the current age of the universe, this contraction will deepen and drastically accelerate. In the Big Crunch scenario, the sky does not grow dark. As the 93 billion light-year universe violently contracts, the volume of space shrinks, concentrating all the energy and radiation that had previously been diluted by billions of years of expansion. The cosmic microwave background radiation, the freezing afterglow of the Big Bang, will begin to heat up, shifting back from invisible microwaves into visible wavelengths. The night sky will grow incrementally brighter, eventually becoming a blazing, inescapable inferno. In the final stages, the temperature of the collapsing universe will climb so high that the boundaries between galaxy clusters will completely dissolve. Then the heat will become so extreme that stars themselves can no longer survive, melting into the cosmic furnace. Ultimately, atoms will dissociate back into their component subatomic particles, creating a fireball of decreasing scale until everything that has ever existed is violently crushed back into a microscopic singularity. If this model holds true, the absolute end of reality will come approximately 20 billion years from now. For 30 years, we believed we knew how reality would end. We found comfort in the mathematical certainty of a slow, predictable fade into the dark. But the James Webb Space Telescope and the latest dark energy surveys have completely dissolved that consensus. We are now faced with three absolute endings, none of which leaves a remnant, and none of which offers any physical mechanism for survival or escape. A cold eternity of maximum entropy, a violent subatomic dismemberment, or a total, crushing collapse back into a quantum point. Because our foundational physics is broken because we are measuring reality from inside a warped, localized void, and because the very force pushing the universe apart is mutating in ways our equations forbid, we are completely blind to which apocalypse is coming. The terrifying scale of the universe has left us trapped in the dark, forced to accept that our ultimate destruction is absolutely certain, yet its mechanism remains a total, inescapable mystery. When we first set out to map the cosmos, we believed that building a larger telescope would simply bring the edges of the map into sharper focus. We assumed that seeing further into the dark would inevitably mean understanding more of the light. But as the James Webb Space Telescope has stared into the deepest abyss of space, it has revealed a truth that shatters that comforting illusion. The title of our journey has been that the James Webb Telescope revealed the true scale of the universe, and that it is terrifying. But as we reach the absolute limit of what humanity can observe, we must redefine what that terror actually is. The terror is not simply the sheer physical volume of space. It is not the fact that the observable universe measures an incomprehensible 93 billion light-years across. Humanity has known the staggering distances to remote galaxies for a century. We have absorbed the reality of a massive cosmos, printed it in our textbooks, and narrated it in our planetariums for 80 years. The knowledge that the universe is large enough to make us feel physically insignificant is a familiar feeling, and familiarity is not terror. Nor is the terror the revelation that the cosmos contains trillions of galaxies, or that there are more planets in the night sky than grains of sand on Earth. Abundance is awe-inspiring, but it is not inherently frightening. The true terror of the James Webb Space Telescope is vastly more profound. The terror is that the deeper we look, the less we actually understand. For decades, we relied on a standard model of cosmology that passed every test we threw at it, giving us a mathematical safety blanket to wrap around the unknown. But Webb did not just peer into the dark, it tore that map to shreds. We aimed our golden mirrors at the cosmic dawn, expecting to find a quiet, patient awakening. Instead, we found a violently chaotic infancy where hyper-efficient gravity forced massive universe-breaker galaxies and ravenous supermassive black holes into existence in an impossibly compressed time frame. We found oxygen and carbon-saturating galaxies that existed before the stars had time to properly forge them. We mapped the cosmic web only to find monolithic structures like the Hercules Corona Borealis Great Wall spanning 10 billion light-years, blatantly violating the foundational cosmological principle that makes our physical equations work. We tried to measure the precise rate of cosmic expansion, only to confirm a devastating discrepancy that strongly suggests our solar system is trapped inside a 2 billion light-year wide void, actively warping our local perception of reality like a funhouse mirror. And when we looked to the future, we discovered that dark energy, the invisible force making up 68% of all existence, is not a stable, predictable constant. It is a mutating, dynamic phantom energy that has flipped its behavior, leaving us entirely blind to whether the universe will end in a freezing, eternal darkness, a violent subatomic dismemberment, or a crushing collapse back into a microscopic singularity. The terror is not that the universe is large enough to make us feel small. The terror is that the universe is strange enough to make our understanding feel preliminary. Consider the sheer audacity of our position. We are a species that has existed in our modern anatomical form for roughly 300,000 years. For almost all of that time, we looked at the night sky with nothing but our bare, biological eyes. We have possessed instruments capable of measuring the distances to other galaxies for barely a single century, and we have had the specific technological capability to read the oldest red-shifted infrared light in the cosmos for merely a few years. We are a shockingly young species, standing on a small rock attempting to decode an architecture that actively violates the mathematics we invented to comprehend it. We exist on a planet orbiting a middle-aged star in the outer regions of an ordinary galaxy, within a universe whose expansion rate we cannot reconcile, whose dominant energy component we cannot identify, and whose earliest history completely defies our most refined models. But the ultimate terror of this scale is what the universe is actively preparing to do with all of this information. The cosmos is not a permanent archive. It is an actively self-deleting hard drive. Because of the accelerating expansion driven by mutating dark energy, the cosmic event horizon is closing in. In approximately 100 billion years, every single galaxy outside of our local group will be stretched across that one-way membrane, pushed away from us faster than the speed of light. They will be completely erased from the sky. Any future civilization that arises after that deadline will look up into the void and see nothing but the local stars of their own merged galactic remnant. When they build their own telescopes and sweep them across the darkness, the deep fields will be completely empty. The cosmic microwave background will have faded into undetectable silence. They will apply the scientific method flawlessly, and based on the scrubbed, sanitized evidence left behind, they will scientifically conclude that the universe is small, static, and entirely empty beyond their borders. They will be permanently locked inside a conceptual prison, completely blind to the 13.8 billion year history we are currently witnessing. This means that we just so happen to live in the exact, brief, and incredibly lucky window of cosmic time where the true scale of the universe is actually visible before it permanently deletes its own history. We arrived late to the cosmic party, but we arrived right before the doors are permanently sealed shut. The James Webb Space Telescope was not simply launched into space, it was launched into the twilight of comprehensibility. What we know right now, what we are desperately cataloguing with our golden mirrors, is something that will not always be knowable. The James Webb Space Telescope has proven that the universe is not a settled picture. It is still unfolding before us, and reality is under no obligation to make sense to our equations. We have built the most perfect eye in human history, only to discover that the dark is deeper, the past is more violent, and the rules of the game are actively shifting beneath our feet. The true scale of the universe is not measured in billions of light years or trillions of galaxies. The true scale of the universe is the scale of our own cosmic ignorance. And as we continue to stare into that shrinking horizon, we must accept that the grandest mystery of all is not what the universe is hiding, but whether we will ever truly understand it before the lights go out forever.